Okay, what if I told you that a simple fraction, the kind you use all the time, once kicked off a massive philosophical crisis and, get this, might have even led to a murder? Yeah, today we're digging into the wild, surprisingly dramatic story of the rational number. All right, so our story kicks off with the ancient Greek Pythagoreans. For them, this quote, all is number, well, it wasn't just some catchy motto. It was the fundamental law of reality. I mean, just try to imagine a universe where everything, from the harmonies in music to the orbits of the planets, could be explained perfectly by simple ratios of whole numbers. That was their whole deal, a universe built on clean, logical, beautiful order.
But what happens when you stumble upon a number that just breaks all the rules? That's where the legend of a guy named Hippasus comes into play. See, he was a Pythagorean himself, but he found a number so shocking, so completely heretical, that it basically threatened to light their entire worldview on fire.
So here's the roadmap for our journey. We're going to start thousands of years ago in Egypt and Babylon, where fractions were just practical tools for, building empires. Then we'll zip over to ancient Greece, where one single troublesome number would spark a crisis that literally changed math forever. And that'll lead us right up to today, where the legacy of that discovery is actually coded into the phone or computer you're watching this on. Yeah, so long before numbers became this whole life or death philosophical debate, they were just practical tools, the literal building blocks of civilization. So let's jump back in time and see exactly how the world's first great empires put these fractions to work. These two cultures had, brilliantly different ways of tackling this. The Egyptians had this kind of peculiar rule. They pretty much only used unit fractions, with a 1 on top. So to write something like 2 over 45, they'd have to break it down into this sum of unique parts, like 1 over 30 plus 1 over 90. A little clunky? Yeah, for sure. But hey, it worked for the really important jobs, like dividing up grain and land. Now the Babylonians, totally different story. They came up with this powerhouse base 60 system. And since 60 can be divided by so many numbers, it let them do these insanely precise calculations for astronomy, basically sidestepping the whole messy fraction problem. So, okay, while these ancient empires are using fractions for day-to-day stuff, the Greeks are over here elevating them into a full-blown philosophy. And that is the exact moment when their perfect, orderly world of ratios slams head-on into one of the simplest shapes you can possibly imagine. And believe me, that collision sparked a crisis that would change everything. And it all started with a shape so simple a kid could draw it, a perfect square. Each side is exactly 1 unit long. Simple enough, right? But the question that was about to unravel their entire universe was this: how long is the diagonal? Now, to a Pythagorean, the answer had to be, it just had to be, a nice, clean ratio of 2 whole numbers. Anything else was, well, it was unthinkable. But then, they used their own famous theorem to figure it out, and the answer they got felt impossible. The square root of 2. This number, this thing, it just refused to be written down as a simple fraction. And suddenly, this wasn't just a math problem anymore. It was a massive crack in the very foundation of their reality. This one moment gave birth to a brand new and frankly terrifying idea: the irrational number. The best way to think about it is like a musical note that falls right between the keys of a piano. It's a sound you can hear, but you just can't play it with the system you have. The Greeks had a name for them, a logos, which means unspoken or even unreasonable, because to them, these numbers seemed to defy all logic. Man, this single discovery sent absolute shockwaves through their community. It completely contradicted their most secret belief. And it drove this huge wedge between the world of pure numbers, arithmetic, and the world of physical shapes, geometry, that would last for centuries. And right in the middle of this firestorm was Hippasus. The legend goes that for the crime of revealing this heretical truth to the outside world, his own Pythagorean brothers took him out on a boat and drowned him. It's a chilling story, right? But the crisis that Hippasus unleashed, it eventually forced this huge leap forward in our understanding. Out of all that ancient fear and chaos, we ended up developing the clear, powerful definition of a rational number that we all use today. So, what's the modern take? Honestly, it's beautifully simple. A number is rational if you can write it as a fraction, one whole number sitting on top of another. That's it. That's the whole definition. Sure, in math we call the whole family of them the set Q, but the core idea is exactly what the name says. It's a number born from a ratio. A good way to picture this is like a set of those Russian nesting dolls. Okay, so the smallest doll in the middle, those are the natural numbers. 1, 2, 3. The ones you count with. Pop that one open, and inside you find the integers, which brings in 0 and all the negatives. The next doll out is our star today, the rationals. This one has all the integers plus every possible fraction you can think of. And then the biggest, final doll, that's the real numbers, which holds everything, all the rationals and all those unutterable irrational numbers. So how can you spot a rational number out in the wild? Well, there's a really simple test you can do just by looking at its decimal form. First, check if the decimal just stops. Like 3 divided by 4 is a clean 0.75. If it stops, it's rational. Okay, what if it doesn't stop? Then you check if it repeats. Think about 1 divided by 7. It goes on forever, but in a predictable repeating pattern. If it repeats, it's also rational. It's only when a decimal goes on forever and never, ever repeats that you've got yourself an irrational number, like pi.
But why do they have to repeat? This is actually pretty cool. It's all because of a neat idea called the pigeonhole principle. Let's go back to dividing 1 by 7. When you're doing the long division, the only possible remainders you can get are 1, 2, 3, 4, 5, or 6. That's it. Think of those as 6 little boxes, or pigeonholes. As you keep dividing, you're guaranteed, mathematically guaranteed, to eventually get a remainder you've already seen before. And the second that happens, the whole pattern of digits is forced to start repeating all over again. It's just inevitable. A really elegant little piece of math.
Okay, so we've got a secret society, a possible murder, a full-on mathematical crisis. Why does any of this ancient drama still matter today? Well, it matters because that fundamental split between the exact, predictable rational numbers and the messy, infinite irrational ones is right at the heart of our modern digital world. Here's the deal. Most of our computers use something called floating point arithmetic. It's super fast, which is great, but it's kind of like trying to measure something with a ruler that only has inch markings. You can get really, really close, but you're almost always going to be a tiny bit off. And over millions of calculations, those tiny errors can add up to big problems. But then there's rational arithmetic. That's like having a ruler with infinite precision. It stores the number exactly as the Greeks would have wanted. One integer over another. No rounding, no approximations, 0 errors. And that kind of absolute precision, it's not just a nice to have. It's absolutely critical. Think about digital finance. A bank's computer can't be almost right when it's balancing billions of transactions. It has to be perfect, right down to the last fraction of a cent. Or what about an engineer designing a jet engine? Tiny little errors are just not an option. When a pharmacist is calculating a medication dosage, yeah, close enough can be incredibly dangerous. In all these high-stakes fields, we still rely on the unbreakable, perfect logic of the rational number. And this brings us to the ultimate paradox, which is just wild. Rational numbers are what we call infinitely dense. That means between any two fractions, no matter how close, you can always find another one. So it really seems like they should just fill up the entire number line, right? But they don't. In fact, they take up no space at all. If you could throw a random dart at the number line, the probability of you hitting a rational number is literally 0. The overwhelming vast majority of all numbers are irrational, the very same unutterables that terrified the Pythagoreans. The story of rational numbers is this powerful reminder that our understanding of the universe is always, always evolving. The ancient Greeks were just terrified of numbers that didn't fit into their perfect little box. And it really makes you wonder, doesn't it? What are the unspoken truths of our own time? What essential ideas are we struggling with right now, waiting just beyond the edge of what we think we know, ready to change everything?